One to another fun live stream and another achievement unlocked. The recurring viewers might remember this SiliconMotion here in this OCO 01, model 01 with SiliconMotion Lynx3d. Lynx3d, if you've never heard about this, probably SiliconMotion, previous video GPU vendor. Nowadays they still are around, unlike others that went bankrupt. So they still manufacture SSD controllers, maybe even Wi-Fi, maybe even still 2D embedded, but somehow without 3D chips. So this previous video, OCO model 01, I got this mostly used already a decade ago for my collection of outstanding CPUs and stuff, because it's featuring a transmitter efficiency of good old firmware. Even Linus Torvalds once upon a time was working. The issue with that is, well, of course, it's somewhat slow, right? Transmitter, did I say efficient? Transmitter Crusoe. Transmitter Crusoe previous generation, so somewhat slowish, and SiliconMotion Lynx3d next to nearly no hardware acceleration in Linux, because whatever, right? Needs an unsuccessful one-man Linux distribution and YouTuber guy to develop this. I mentioned in the previous video, even the original vendor gave up on 3D. So SiliconMotion Lynx3d, the only ever existing 3D driver in existence, as far as I'm aware, for Windows 95. So who is gonna use Windows 95? Certainly next to nobody, right? And the vendors, of course, knew this OCO 01 shipped with Windows XP Tablet Edition. So even from ex-Apple or whatever startup there in 2003 or whatever, many years ago. And so hilarious, right? I mentioned this in the previous video. Hilarious that the original vendor for Windows XP Tablet Edition, they shipped it with a not 3D accelerated Windows driver. It's hilarious in my opinion. This is, last year I enabled this here, similar to the low-level stuff, because very long time ago I actually found here the specification. I showed this last time here, our fun little hobby of enabling graphic acceleration and 3D acceleration for each and every fun little chip set. And I found this previously, this was on their FTP server where I grabbed it already a decade ago. It's not there anymore, unfortunately. I think they now want a password on the FTP server, so not really sure if it's still there. And why do I do this? I want to document not only you can do this at home, really just grab what you want to use, like you like this transmitter, fishing, hobby, vintage fun, or voodoo or whatever, SG02 or SG Octane or whatever retro vintage stuff you fancy. And yeah, just write some code, right? In the afternoon, better than my recurring theme, better than Tetris and stuff. So you see, even unsuccessful one-man Linux distribution guy and YouTuber can do this here in a couple of afternoons. And I've done this last year, and the code is here, of course. So, yeah, I need to be a little bit careful overcharging this battery. Anyway, the code is here in my repository. It was already last year, similar to the Verge Voodoo. What else we have done so many in the meantime, not to mention PS3 RSX, but Verge Voodoo, what have we done recently? It's a ton, yeah. Matrox, Permedia 2, did I finish that? And plenty more. Anyway, so when we soon start with our microkernel, at least we have a handful of working hardware isolated drivers and stuff. So this code I've done last year, a long live stream, and I got somewhat frustrated because it wasn't fully working. So why do I share this? So a couple of things to learn. So first thing to learn, even if you have a specification which recurring theme, no thumbs up for NVIDIA, for not, this is how specification look like for not releasing the specification. Intellectual property my ass. And also two more things. So another thing is, even if there's a specification, very few people get up their ass off their sofa and do something for the community and write a freaking driver. There is, of course, an X driver, and the crappy, the frame buffer driver is so crappy it accidentally. So not only the frame buffer driver was broken for a decade, it resulted in garbled screen, but now it's like it wrote too many registers there and collaborates the CRT registers. Someone fixed this for whatever, maybe an IBM ThinkPad or something. But now at least it's not broken. After a decade it was pixel garbage, now it's not broken anymore. This is right now Linux running, certainly our T2 flavor. And now it's upside down. It's like, yeah, after a decade it's not broken anymore, now it's only upside down. So yeah, whatever, you can see this more, yeah, upside down because, you guessed it anyway. But also still no 3D driver, right? So there is a basic X driver, which of course X2D, XAA, somewhat unfunctional because it was removed from the X server a decade ago. But anyway, so even if you have the specification, and this one is actually not too bad, this is really set that in the Linux ecosystem, maybe also because with not a fan actually of the Linux setup of direct rendering manager, X server, you have like 3 parts, Mesa, not very nice to work with, and it's probably also why I will not upstream this anyway, because I better write my microkernel. And so yeah, many lessons learned, including like you can contribute to the community and do the stuff yourself. But another thing is, this is often in the specification, they go here in great deals of all the pins that I'm not even interested in. And fun fact, I would even be more than fine if more companies release specification and they do not even, if it's for me, well, repairability and stuff, but I don't need the pin out. So many of the specification go here in great deals with pin out and electrical characteristics and whatnots, like, yeah, YOLO, whatever. I don't even give 2 cents of whatever. But what many of the specifications have in common, even ATI and Matrox, and maybe even, yeah, for example, VIA, maybe even some ATI, AMD and Intel. A lot of stuff is in great detail, and then the 3D stuff is a little bit spare here, sparse. And so I got this somehow to work a little bit. We can run this a year ago, but it wasn't fully working. And basically I got this vertexes and textures. This is, by the way, secure shell there, obviously to the OCO for usability. And do we not have, oh, here. So rerunning this, that you see there. We can also have this on the big screen here, because obviously I'm not working with this rotated. Yes, running on NTCV node. Just need to check if I show the right one. So our regular test setup of, just probably should shortly check what I show you there. Yeah, also wrong this input. So our regular test setup, the recurring viewers know this, of course, from the Verge Voodoo and other test setups. Our low-level stuff, usually we run it on DOS for microkernel preparation, but Garrote shaded triangles, maybe even set buffer working, filling, bit building, so a lot of stuff working, except texturing. As you see, texturing quite garbled. And another lesson learned, so I honestly spent way too many hours on this. So I gave up last year because, whatever. And it bothered me a little bit that this stuff wasn't working after I spent already quite some, probably 2 or 3 afternoons for this basic enablement, and then the bloody texturing stuff wasn't working. And yesterday after P3 live stream, I had this in my hands, and I was thinking, like, with all the Verge, Voodoo and Matrox and ATI, it's really sad that I'm the only one, not even the vendor, previous video, not even the vendor has done this. I have it somewhat working, but it's not like fully working. I was already thinking, is this texture unit so broken? Is the hardware like manufacturing defect? Is this why the vendor never did a Windows NT, Windows 2000 XP driver thing? Is there hope for this thing? And I spent yesterday probably 3 hours after the P3 video, and lo and behold, at 11 I actually went home. Recurring theme here. Maybe I should go earlier home and have fun with the family. But yeah, at 11 I made some breakthrough. I basically bit banged the stuff out of this. And what would you think? How I got this to work is actually bit banged this registers, tried a lot of stuff, modified. Would I even show you that down? I really need a third display here. it's not really scaling. Not picture. Okay, picture actually maybe not too bad. Can it do? What would be the second picture? Can it do analog and video? Whatever. Somehow not the most motivated to use picture. Also, what do I show you here? I wanted to show that. So okay, can we stop this fail of picture? Darn it, here, garbage display. So a bit, I tried a lot of values here like this and whatever, and it's like, what the heck is even going on? And there must be some system in this. I added their test pixels of like black and yellow and blue dots in some pattern to better understand what the bloody texture hardware is doing there. And after staring at this stuff for 3 hours, I natively zoomed that I must write there some registers in some wrong way, because obviously it must be my register writes. And the issue is, as usual, under documentation of the 3D stuff, where is this even? OpenGL here somewhere. And I mean, I need to be somewhat thankful that at least it's somewhat documented here on this NVIDIA, where we get nothing. Here's a NVIDIA finger. And the issue is that this is not more specific. Although it's better than nothing, but yeah, there's only so much you can do. Most of the stuff here that is documented is actually working how it should. And it's really frustrating. You write these values like X, Y, Z, STU, like XY texture coordinates and stuff in these registers, and the hardware is doing whatever, but not what you expect it to do. And this is also why what I mentioned, the 3D documentation is often a little bit sparse, and if something is not working, I had here already so much stuff to guesstimate to get working, and yeah, so the documentation is not helpful. I'm writing it in there how I should. I tried already many variations, like this way, that first, another way first. So yeah, whatever. Of course, usually the documentation should like do that first. For example, you even need to guesstimate here a little bit from this little bit rushed documentation. Here is like 3D and direct OpenGL vertex and 3D. This is also not really explained. Only after some thinking I figured, these are the same registers in memory, and depending on whether you enable direct 3D or OpenGL, this vertex registers are at a slightly different location, and slightly the biggest difference is for OpenGL the colors have floating point formats here, RGB-A, and for direct 3D this is why these registers move all a little bit. So I thought like maybe this direct 3D stuff is broken. I already switched it to OpenGL, changed all my code to use OpenGL register. It also doesn't work. So yeah. And after 3 hours of another, so in total this costed me already probably 5, if not 7 days of 2 or 3 hours after work, 20% fun. So long story short, what is the issue? I got it to working to my own surprise already. It was like, is this silicon really so broken? What am I overlooking? So turns out, let me show you that. Turns out after a lot of guru meditation, this texturing is not linear, and this is really to my surprise. That what do I mean by this? So normally all the early or later stuff, the texture is linear in memory. And with linear, this means, let's show you maybe that here. So linear versus tiling is, if you have a picture in computer science, you usually have this linear, meaning first all the X major pixels in some two-dimensional array, similar to probably this here, 0, 1, 2, 3, and this is how probably, yeah, you want to share, like, and subscribe. I probably have to do some low-level 101 programming series here. So this is how you would normally do it in a frame buffer in your own program. And this is not the most efficient for caching, because if you interpolate here and you have a not small but larger image and you interpolate from 2 pixels, then this is like your whole X major stride as in maybe 1K, 2K, depending on how large your image is. And if you interpolate around here like x0, x1, x2, x3 on linear interpolation or something, you cause really many cache misses and thus memory bandwidth. And this is why 2 decades ago, certainly around the time of this fine silicon, they invented tiling. In tiling, this is grouped in tiles of 8, 16, 32, depending on the hardware and software configuration, so that you have tiles of 8 by 8, 8 by 16, and then you repeat this here like in memory addresses 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then the next tile is depending on the hardware and software. Here's the next tile. This improves cache utilization and memory bandwidth vastly, especially for texture interpolation, for example. I just didn't expect this. Normally you have in the documentation like tiling. The reason is, so the whole document, like tiling is freaking 0 times mentioned in this bloody document. Also like swizzling or something. Swizzling here also, not like another term for this is swizzling, for example. And yeah, this bloody documentation, so much to, it's not the first time, it's already the second time I had this with something else. I forgot what it was, but probably the recurring subscribers and viewers can remind me. We had once already this where having the documentation cost me many hours, like 3, 4, 5, 6, 7, 8 hours of losing time because it wasn't documented. And if it's not documented, you expect stuff to work in a certain way. And yeah, so tiling here, like here, not so much to, if it's not documented, even if you have the documentation, you can easily waste days because the documentation doesn't mention some detail. If they would have mentioned this here somewhere, like texture, so even with texture format, mirror texture, so I reread this, all the stuff. I mean, kudos to SiliconMotion, certainly multiple magnitude better than bloody NVIDIA for thanks for nothing NVIDIA. But yeah, it's mentioned in nowhere. You can believe me, you can also search this and read it yourself. And yeah, if they would have mentioned this here somewhere, it would have easily saved me a day or two. Let me show you this to get this to work. Of course, I had this already to work, so this is only the quick rundown and summary of this stuff. So let's show you how this works. So we had, of course I tried this already. It took me here another hour this morning to get this to work. Also coffee, but also so much to motivation and dedication. A lot of people would have given up. Even I gave up last year because not important. Have better things to do here with this hardware that nearly nobody has, except also some ThinkPad like T42 or something, one Japanese edition ThinkPad. So this, it wasn't the highest priority, but it bugged me again. I mentioned this already. Bugged me a little bit that I spend so much time and then it doesn't work. So the proof. So this is not a full 3D engine, but we're getting there. So next we do ATI. Maybe we finish Matrox because it bugs me also that I didn't finish Matrox. Maybe I finish Matrox and then we do ATI. Maybe not in that order, but we also do ATI, NVIDIA, like old fame, ATI Mach and Rage and NVIDIA Riva and SCS, just for the fun of it, and VR, because there also is no working Mesa VR stuff, right? So this is, soon we grow this into a real Mesa-like, but in more readable modern code 3D library, because we have nothing else to do here in our live and YouTube channel. So the structure here right now is the same as with Verge, Voodoo, and all the other Matrox, Permedia. Like I've done 3D Labs Glint already. Maybe I've not shown you that, but I have 3D Labs Glint because it's also not really a Mesa driver anymore. So the structure is the same. I want to say the structure is the same for proof of concept. And so this is my test pattern stuff that I added. Initially I only had, so we load the texture like similar to the Verge and Voodoo, and what did we do the other day? Something, whatever. Usually we do this on DOS, and because this OCO doesn't network boot it and DOS like whatever, it's not the easiest. So we exceptionally run this in Linux, but this doesn't really matter. We run this, we map some registers and bitbang the registers from user space like you would do in a microkernel. And as you see, I added here more and more to understand how this tiling stuff works. I added here more and more test patterns. First, the very first pixel black, like 0, 1, 2, we have RGB, A-frame, test black. Then a white pixel, like 4 pixels further, test white pixels, and also a yellow pixel, like really because we have our textures 128 by 128. So I wanted the second line, like after the first scan line of texture, the first pixel of the second texture line, yellow here, as you see, 128. RGB test yellow, and I had this already. Maybe I even had this probably last year. Didn't get much further with it. So yesterday I added a whole bunch of okay, let's every fourth freaking pixel, and let's try to understand there must be a system in this. And I think I run this right now. Let's and then I also go through. Let me just show you that, and maybe a little bit higher. I think probably need to have here multi-monitor stuff of even more multi-monitor for even better. And there you see how different it is, difficult it is. It took me really quite a while, because who of you would have guessed with this test pattern here that this is freaking tiled, right? Of course, there will be some smart pants in the audience who say, I've seen this immediately. So this is, you see the registers, this is the size, this is the X and Y size of the texture, and like I was sitting here like guru meditating, and then eventually it really struck me like, wait a second. So I spotted there eventually with 20 years of experience, it's like, wait a second, this is freaking tiled. And so this is, by the way, iterating in the texture size registers. And so as we finally established this is freaking tiled, let's tile this. So even that wasn't as straightforward. So let's see, tiling, test pattern. Here we only upscale, so the texture is 24-bit RGB. So we upscale this from the Virgin Voodoo example to 32-bit RGBA. Not really much to see, so the tiling is here. And even the tiling took me like an hour of trial and error, because I didn't really... I saw the tiling pattern is 4x4 here of that tiling here, right? And I only wondered what wasn't clear was even the quite some, how many did I had there, quite some of with all these test patterns. I spotted it's 4x4, but I wasn't sure if it looked strange. It looked like this, like first tile here, like 0, 1, like 0, 1, 2, 3. And I wasn't sure how the hardware was using this, because we have 128 by 128. I wasn't sure if the hardware is filling it like 0, 1, 2, 3, or what the hardware exactly is doing there. Not in the documentation, right? And so I started to tile this here, like here. So for that I have a second texture address, and I switch this here. So I create a second tiled texture behind our first. So the new texture address is 128 by 128 multiplied by 32-bit after our actual texture. Then we have a tiling width. So initially I started with a tiling width and height of 4x4, but that didn't work. It certainly changed the pattern, but it didn't look correct. This is what I meant. I wasn't without documentation. I wasn't sure, is this 4x4? Is this what kind of, because NVIDIA, Intel, there are all kinds of different swizzling zigzag patterns here of NV12. You see it's 0, 1. I was sure it's not this, because I saw it's 0, 1, for example. And as far as I'm seeing, it's a little bit strange that it's somehow 4x8. I determined this by trial and error for whatever strange reason. But even that took a couple of, is it this, is it NV12, is it whatever, is it 4x4, 4x8? So I see so far it's 4x8 for whatever reason. So for this tiling copy this texture for all the base Y, for the texture size, from base Y to base X. Always add the texture size here and then iterate in each X and Y here of all the tiling, and then in all the tiling pattern store it linearly. So what we do here is we have a linear I that we increment for each axis, and we linearly fill our texture and iterate here in this tiling pattern. Probably again next videos some more stuff. So yeah, sounds a little bit, I try to my best to explain it for you playing along at home. I hope that makes somewhat sense and is understandable as usual. If you have questions right now, that's what the live streams are for. And so yeah, with that, let's compile this. So yeah, it takes a second here on this transmitter Crusoe it takes 10 seconds to compile this. It's a gigahertz. So it does not immediately look correct because I still have the code here in place to with all the presses iterate texture sizes, but it looks already better, right? So we iterate here the sizes. I hope it's on, should be on, is it? It's barely maybe on camera. So again, this is a memory mapped IO register for the texture format and size, and the correct size should be 7 by 7. And when we approach this here with my key pressing here you see this already looks so much better than previously, obviously, and bam, we have what is a little bit strange. I'm not really sure what it's doing with, but this is 7 by 7, like 7, 2 to the power of 7, 428, and who thought this unsuccessful one-man distribution and YouTuber gets a freaking texture unit under control. You see here this fine little test pattern that we write in there. No, obviously in there. Fine little Lena test texture here out of the SiliconMotion. So as I said in the previous video, not only has all of the SiliconMotion, there never was a Linux driver. Which camera do I even show, this or that? Probably should move our OBS over here. As I mentioned before, there never was a Linux driver, and there never was a Windows NT driver. So all of the silicon, so most likely all of the silicon ever shipped, and so not only in this OCO, I think there was, what was it? Was it in the Limode Longzone MIPS, Chinese MIPS netbook, something of that sort. I think it was probably in this Chinese Limode MIPS-based Longzone MIPS CPU netbook. This is why they, after a decade, fixed this random garbage there for either the Limode or the IBM Think. It was also in some IBM ThinkPad like 42 something, I think. But don't quote me on that, Google that. So there are some millions of devices, certainly. I mean, this company is not stupid, right? They certainly, I think it was also maybe on some server boards or whatever. So they certainly shipped some millions of units in ThinkPads in this OCO. Certainly the OCO, not really sure how many they sold. Maybe they sold some 10,000, 50,000, no idea. But ThinkPad, certainly IBM, this was back in IBM fame. So certainly the ThinkPads they sold probably, hopefully for IBM, some 100,000 and so on. So it adds up, and this is crazy, right? In software and hardware land, we are in a situation that the vendor is not even delivering a freaking Windows driver. And this hardware, the ThinkPad, all the hardware has never seen this logic gates flipping on and off for delivering hardware isolated 3D drivers, and it takes an unsuccessful one-man Linux distribution and YouTuber guy here after a decade or two to finally write a freaking 3D driver, because I think, mentioned before, Windows NT stuff, 2000 XP never had a 3D driver. If you wanted to play a game, certainly very early Silicon, back in the days, whatever that was. By the way, if you have a SiliconMotion, I would love to get my hands on a SiliconMotion LM, a Lynx 820. Maybe there was even a PCI card, not really sure. Don't find it on eBay. If you in general, if you want to donate, if you have hardware in the attic that you never use, like outstanding stuff, maybe drop me an email if you want to donate it for having fun here. Anyway, I find it insane that all the hardware shipped and was never used. I mean, this is mind-boggling, right? Shipping hardware never used. I forgot actually to revert here something. I wanted to show you something else. Another thing, so even when I got this working, so this is a live update, right? I only got this working this morning. I got the tiling clues last night and only working since this morning. Just implemented tiling here an hour before the live stream. And actually there is something else strange in the documentation, because usually, and again, not tiling, swizzling, not mentioned bloody at all here. And another thing is strange here. So, because when I got this to work, did I already commit this? Maybe I did, maybe I didn't. Let's see. Apparently I committed this already. Being a good citizen, committing early and often before you transmit to phishing. By the way, I need to plug out the power because I didn't hook up the power supply correctly, and I'm currently overcharging the battery because some of the battery charge controller gets confused if it doesn't get the right voltage on the correct, because anyway, I digress. So what is strange in the documentation is, where's our triangle? Triangle is here, and here are this is only proof of concept code, right? In our long-term Mesa replacement, think LLVM for Mesa replacement, because I'm so tired of this software quality. Anyway, so here are our W, S, and T parameters for the texture. What this is in texture land. So you have vertexes, vertex 0, 1, and 2 for the triangles. And then you have also the texture address. And because we have already X and Y, the reason why in 3D stuff, usually you have to deal with other coordinate systems like U and V, or S and T, is because you have already X and Y for your 3D world. This is why usually the texture coordinates are S and T or U and V or whatever. It depends on the vendor and the book, what they use. And so the texture coordinates in this amazing documentation here, this is a little bit guesswork, because as I said, it's so not only this 3D, direct 3D versus OpenGL, not really, you need to guess a little bit, and it's not documented what kind of unit system, whether it's 0 to 1 or 0 to texture size. It's a little bit off, to be honest. I'm still not yet sure, even after trial and erroring so many afternoons. So here we have SWI1, and here we also have S and T. So this S and T, of course, it's not documented here. I only knew this of 20 years of experience. Of course, S and T are the texture coordinates. And usually for me, S and T is also in the Verge and probably Voodoo. S and T, like S is X and T is Y in the texture space. And I flipped this here already. So usually we have here, this is a little bit of a hack, again, testing hack. So usually I want 0, so let's see, 0 and size. So this should be X, so this is our test triangle. We have this positioned at, our test triangles are 0, this is vertex 0, so from here to here and here. And so we need to lay out the texture so that, again, not a full 3D engine, this is coming next. So usually I had this here like, like that size, come on, size and 0, because usually I would naturally expect the texture X to be S. Also comes first, right? X and Y and S and T and U and V. So this is our first vertex here. This vertex 0, 0, 1, 0. So let's revert this. Oops. And this is how I had this, and this is revert. Let's just, as we unlock this, probably I had this committed already, right? I committed already at 12:30. Restore and tiling freaking texture here. So let's show you that change that I reverted this here earlier. Yeah, this was 0 W size, and yeah, reverted this already. Let's recompile this and show you the effect and how this is flipped. and just another testament of not only often underdocumented, but even the hardware might sometimes do. I really wonder, I mean, I wonder not only why do they have not freaking mentioned the tiling and swizzling here in the freaking documentation. Also we have an error in lines 352 of size, of course there is a parenthesis missing. And let's see. So this is how it looks when S and T are flipped. And so we basically probably should change this. Now that we have this working, I can remove this global variable of texture size. Do I even show this? Hopefully, apparently. And so we need to get to 7, texture size 7. And there we have it, boom. And as you see, it's 90-degree rotated. What happens if you mix X and Y in the texture buffer and have X and Y flipped, then obviously, right, like S and T, and yeah, not really, I've not seen that, so the hardware is a little bit near, but now whatever, now we know how that is doing. We can, by the way, live, let's show you probably that, and I hope that is right, it's good. Let's maybe remove this global variable. I had here gtext. This was just from having the test driver, what I resorted to last year already. So this would be G, or wait a second, let's not delete this. Let's gtext. Let's not delete this, but instead have here text level. So this is X and Y. Right now we have only square textures, doesn't really matter much. The very early was it the Verge? Not really. Anyway, the very early hardware like the Verge, maybe even the Voodoo, only supported square textures, and only later they supported rectangular textures. And make this again, make it G++s. And all the early generations, like the first decade of hardware, they only supported power of 2, meaning stuff had to be power of 2 size of 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024 pixels. And I think we restarted. Let's, do we even show this already? Maybe not. Now let's press here. Do I show this? Oh, it's a little bit. So let's distort this. This is of course running frame buffer, right? So let's distort this and run this again, but I guess this probably should have run. So the change is that instead of having our global test variable, so yeah, now it's except certainly X and Y, we still need to flip. This was S or whatever here. Know that of course it's not a big deal. It doesn't prevent you from writing a driver. What do I show you? Probably that. You just need to know. For me, it doesn't. We could theoretically even change this in our, when we make this symbolic register values here, we could just change this right now. I have this here for testing purposes. I have many other registers already, nice symbolic ones somewhere here, like yeah, here like Lynx registers here of stretch, source, y, whatever. But next I would need to make them only nice, pretty. So we could theoretically already swap this name for us, and so that we know that is like S and Y, it's, yeah, whatever, a little bit flipped, so, but yeah, not a big deal, you just swap those values. Theoretically, another day, also, you can delete it too much, only 3, 5, 6 here in our action. Next I would need to try all the different sizes, if they all actually work. I think it looks to me, because I iterated already through all of them. Now we have to even show this, maybe not. But now it comes up correct. And so theoretically, nothing prevents us now. I have like basically everything working as far as I've seen here. We could write, but whole 3D engine, another day we do. Not necessarily for the Lynx3d, but like similar to Mesa, what they deleted there, good old-fashioned fixed function pipeline. And what we need for a real game and stuff and operating system is a front end like good old-fashioned Mesa, but more readable, modern C++ or Rust or whatever code. Go, you name it. Leave in the comments below what you like the most. So next is just taking the API like Direct3D, GL API stuff that the game and programs send to the 3D engine. And what I would want to do is one like GL API, and I would structure it so that we have the vertex data and have similar to Mesa, and not really sure what was holding them up back in the day, but I see no reason for this fixed function. Also, yeah, good old-fashioned, yeah, certainly for Quake 1 and 2 and maybe 3. Certainly not vertex shader and fragment shader and fun stuff. Fixed function and so on, but yeah, nothing wrong to use for accelerating your window movement. That is certainly what we do next here. We want to share, like, and subscribe for this fun little ride for microkernel with real windows and nice little stuff. The only thing I wonder is this stuff has support for AGP. Actually, slightly wondering whether it is AGP like connected here to the system bus. But so this has even documented here AGP and texture base register. So the high bit is simply, if you set the high bit here, then this is AGP coming from system memory. I only wonder if the system memory textures are also tiled like that. That would be a little bit inconvenient if you would want to build like transparent windowing system, like here's this transparent, nice little windows, right? If you need to tile and swizzle them in system memory, that is somewhat inconvenient for programs. However, certainly you could, of course, make this work as well. You just, well, certainly modern hardware, NVIDIA, Intel is doing it anyway. You just need to write your Windows server for a 2D transparent window environment so that the applications, either if the application should directly, like Firefox and some terminal, should send their application window directly, like memory mapped their client window, then of course they need to be aware that this texture format is tiled and swizzled. And yeah, certainly you, even in a modern stack, certainly have this here with NV 1.2 and whatever fame. But yeah, this is, if it's not documented, then it's trial and error. I'm totally happy that this works. Also, how many drop frames? Hey, 0 frames, amazing stuff. Yeah, so leave me in the comments below. Maybe I'm potentially more happy and satisfied than you there in the audience, because hey, I spent all my time getting this to work. For me, nice achievement unlocked. This is really a joy and pleasure to see this vintage hardware, not only the Sony PS3, but also SG Octane. Theoretically, we have still the same to do for the impact there on the SG Octane fame. But as you probably noticed, I try to make it also interesting for you, not to do here a whole quarter of each day, like 3 months of PS3 RSX stuff, but yeah, for you to learn what tiling, linear tiling, swizzling, what kind of fun stuff exists, and that certainly specification is amazing. Even more amazing if it is error-free and fully documented, because again, tiling, swizzling, not mentioned with one word. And even then, yeah, AGP texture memory, certainly a whole other trial and error adventure. Certainly something I wouldn't enable in the very first revision of our own GL engine stuff, or yeah, 3D engine stuff. Host-based DM8 stuff. First, correctness. I will target sometime soon, also with AT NVIDIA and all the fun stuff that we want to use here, is correctness first. Like first the stuff, it helps you a little if it's high performance and if it's crashing and leaving graphic artifacts. So correctness first. By the way, this demo here already using set buffer. What do I even show? Do I show that? Hopefully I show that. So this is already using set buffer. So this is basically using all the features that are in there. Set buffering, growth shaded, textured, bit BLT. So basically everything we need for our fun little hobby microkernel 3D engine OS working. And yeah. Anyway, that's mostly it for today. Let's see if we have consulting questions and features. Again, I'm totally thrilled that this works now, and certainly an interesting thing that you're the only one person in the world ever, not even the vendor has done this. So yeah, welcome there. Graphic card only have one tiling mode and one texture format. Just question because don't have linear is wired, isn't because don't have linear is wired. Well, so the modern, well, for me, it could be that there is some hidden bit here somewhere that's not documented. It has more than one texture format. Good question. By the way, it has more than one texture format, but this has very little. So this Lynx3d, it is amazing that it has 32-bit RGBA, but it doesn't have much more. It has 16-bit and palette, and that's all. So only probably even the Verge and many other earlier have more formats. And even the, what have I done recently? 3D Labs, what was the other? Actually, I probably can check what links. Alright, Imagine 128. Many have more formats, and so what this means is, for me, it's better. It has like 32-bit. Here's the formats. No, this is frame buffer. Where's the texture? Frame buffer here. So it's like this. Yeah, also compressed. Whatever. So this has only, yeah, very very few. There is even palette in. Is this palette CI? Not even sure. But the good thing is you can in your 3D library, this is not the worst thing. I rather take this like 32-bit because you can upscale this texture formats. If your game like Quake has some whatever, and it's better you have high definition texture format, except wasting a little bit video memory, but at least you can convert them. If like Verge or Voodoo might not support this, you can at least, well, you can also down convert them, but you certainly use the fidelity. So yeah, for me this is pretty okay-ish. Like it's like wasting some memory, but up converted. And also yeah, 4-bit RGB. Then this is 16-bit, of course. This is a little bit strange. I don't quite know why they have here YV16 RGB 565. I'm not really sure where you switch. Why does it have both? Where is the toggle for YUV versus RGB? Not really sure. Maybe this is indexed CI, maybe this is color indexed 8 or something. Also not really sure where the palette is coming from. Or was it? Maybe there was a palette base. Where was this even? Right of global fog. Ah, right. I think it was shared with texture palette, right? So this is node like global fog space. So this also means this is often a little bit inconvenience in this early silicon or fixed function. Often this is also the case in the Verge or maybe Voodoo. Sometimes you cannot use all features at a time. You see, you cannot use fogging, like making this gray or gray or red fogged there in the distance. You cannot use this together with a compressed or palette texture here. So you see global fog space lookup table RAM will be shared for global fog here for the fog LUT as well as for the texture palette. So yeah, no fogging with palette textures, but yeah, whatever. Anyway, so this will be a little bit challenge if we want to make a 3D engine that really supports all the features, because encoding somewhere what can be used, if we want a generic API in front of this, we somewhere need to have some means to tell the high-level code what kind of stuff can be used together. Maybe it's as simple as a Boolean, like 12, 16 features of common stuff found in the Verge Voodoo, of no fogging with alpha, or no, I don't know. It's not the highest priority for me. It's already amazing that this works now. One achievement unlocked there, and you can sleep in peace again after having solved this mystery. And what a mystery that was. Anyway, that's it for this video. We should keep them somewhat brief. It's already, with all the talking through the details, long enough. But amazing enough that so many people tune in. Morg says this, greetings everyone who tuned in. Also, I can probably switch to this other, wait, I can't read this comment anymore. If we switch to that again to show you that fun little stuff, and VGA, and then switch to that, scene. So let's see why we read the comments here. Next, of course, I need some better demos. So I'm not really sure how the problem is that the GL API is relatively complex. I'm actually aware that this camera is not fully focused. I forgot to, it's more focused. Usually switch to manual focus, otherwise it constantly gets out of focus. The problem is that the GL API is relatively complex, so I'm struggling a little bit between implementing a mini GL for this and our own microkernel OS. Well, okay, maybe in the long term we need GL anyway, or except GL is a little bit on the way out, certainly with Vulkan. But I'm struggling a little bit between implementing a mini GL API and writing some, or the benefit is if I write some mini GL, we could eventually have GL Doom and GL Quake running, maybe theoretically someday, and some demos. The disadvantage is that having some mini GL stack is already relatively complex, and yeah, not really sure. But yeah, one thing is for sure is we need some better demos, because with all this amazing stuff here, Verge Voodoo, number 9, Imagine 128, Revolution 4, 3D Labs, Permedia, and Matrox, and ATI NVIDIA, SCS, VR, and fun stuff to come. We need better demos, because this demo was, of course, in the early days last year when we got into low-level new driver code, was, of course, better than nothing. Here our, again, garage shaded, I'm not even sure, maybe I've accidentally, this might have accidentally spectacular lightning on. I think I see some light shadow over that, but yeah, basically, but again, all the bits and features, all the basic, like flat, garage shaded, maybe even spectacular lightning for a test, texturing, so everything you need for a real 3D engine. Now the only thing is a nice API and wiring on. Of course, what is missing is wiring up some more features. I have some stuff hard-coded here for the demos, so this is, of course, a little bit of work in terms of wiring here, this triangle stuff, for example. Theoretically, of course, I have here already some stuff which is better than nothing, but we need to wire up here more texture coordinate control, where these vertexes fall on the texture. We need to wire up specular lighting, specular color if we wanted that. Certainly we want someday. This texture coordinates. Some of the stuff is hard coding from testing. I'm also not really sure how on this particular hardware. On the other hardware, it was either the scaling of the texture format was either 0 to texture size, like 128 in this case, or -1, 0 to 127, or 0 to 1. Verge Voodoo and other hardware. For this hardware, it's a little bit strange. I'm not really sure how the scaling works, because somehow it's like, maybe this is a maximum texture size. Maybe it supports a maximum texture size of 2048. Let's see, this could actually, so this would be 2 to the power of how many bits we have. We have 4 bits. This is, no, this also doesn't. How many bits would it be? This would be 11 bits. anyway, maybe that is the maximum texture size. Anyway, whatever this fun scaling is here. Yeah, to this number I initially had here something, probably initially I had here 127, I guess, and with this obviously it didn't look right, and then was trial and error until the scaling was right. So yeah, but if you write documentation that is also for your documentation writing what kind to document, this is this kind of stuff that I always a little bit lagging here. But again, kudos to SiliconMotion to once upon a time having this on the FTP server, which is already a magnitude more than NVIDIA ever had. So thank you, NVIDIA. I'm not giving you my money, unless maybe used third party or on eBay used secondhand stuff. But anyway, yeah, amazing stuff. I'm totally happy. Nice happy Sunday now. Mock writes, channel is underrated. Thanks for that. Extremely underrated stuff. Making these able to put off making these kernel things is not understandable. So great stuff. Keep it up. Yeah, thanks for that. Hope this is sorted in a way. You see, I already prepare here for hours actually after yesterday's live stream, P3 live stream, previous video. Maybe I should have actually rsync the ISO, but instead I spent here 3 hours. It really takes a long time, even if you have the documentation. And if you don't have the documentation with NVIDIA and others, then it takes even weeks and months of writing wrappers, MMIO trays, tracing it in one way or another, either MMIO trace on Linux or virtual machine tracing with a Windows VM, and deriving all this NVIDIA secrets values there in Novus fame. But yeah, hope you learned something also, that stuff doesn't need to be stored linear. Stuff can be tiled, swizzled for, and why certainly. You see this is a little bit for the hardware. For the hardware it doesn't matter much. Similar to my memory controller video for the SD memory on the FPGA. Swapping this in hardware is super easy. You just in Verilog or so just move some bits around, basically XY. You just move the bits in the memory addressing, and it's super easy. Like it's like basically free. It's not any performance penalty. It's like for free, moving, rearranging some wires. But in software, it's a little bit inconvenient, as you see, at least for this open coded test here of tiling. Is that the right file? Maybe it should be the right file. Maybe F1 of all code runs off here. Tiling, did I not tile? You see, it's a little bit inconvenient here. This is of course open coded, but in the long term we even need helper functions for that in our own 3D engine, 3D libraries, so that you could you can already specify the tiling size, but certainly it would be good if we have some helper function to specify tiling, width, height, swizzling pattern, this or that, zigzag, whatever, and have this transparently, of course, another day handled there. But yeah, in software, more inconvenient in software, also not too much magic, just instead linear again. But live stream, because we're not showing you my collection of vintage cheap eBay 3D Labs per media stuff and what is coming next. But I probably also should next have a better demo, maybe some flying spaceships here of X-Wing versus TIE Fighter, and also add here some more texture formats for better testing, so that we have one to test this here ultimatively. Have here 2 different textures, like one gray and one smaller, to test the scaling, so that we actually test here that it's not hard coded, because it's something else than having this hard coded here for one texture, like the size stuff here, but have 2 different textures, so that we see that also too many camera angles, so that we test all the different registers are written correctly and updated, so that we have actually in another, yeah, actually right, in the DOS example, what I've removed in the Linux example, because it's right now running in Linux, right? In the DOS example, I have already this with the timer interrupt animated, I just remember, so that is already testing this grout shaded triangles better. So we have on the DOS low-level demo, we have the one grout shaded triangle from red, green, blue spinning here, and we have actually this linear texture animating here, getting smaller and larger. Actually fun little stuff that in DOS was even somewhat easier with the timer interrupt. Just hook up the timer interrupt and have say 18 times a second on the default DOS BIOS stuff anyway. So yeah, but hope you learned something, tiling, swizzling, and that at the end we get each little silicon stuff working here. Welcome, Danny. Amazing to see everyone back. We are through with this topic. Maybe I actually really make another video. Let me check what time it is. But in any case, hope you learned something, and don't forget to share, like, and subscribe. And I hope to see you soon for all the next videos and live streams to come soon.